Hello everyone, let's look at 3sum. The problem statement is we are given an array of n integers. We want to find 3 elements in this array such that the sum of them equals 0. And we want to find all unique triplets in this array. And the solution should not have duplicate triplets. Let's look at a couple of examples here. So for the first example, this is the input array and the output triplets are -1, -1, 2, and second one is -1, 0, 1. For the second example, the input is an empty array, so the output is also an empty array. Third example, the input array only have one item, so the output is also an empty array. To solve this problem, we can take a couple of steps here. First, let's consider if the length of input array is less than 3. Then we simply return an empty array, like example 2 and 3. Second, unlike the 2sum problem, we don't need to return index. We just need to return the value as a triplet. So we can first reorder the input array. For example, this is a sorted result for example 1 in an ascending order. Then we can loop through the array, fix the current value, and then use 2 pointers to point at the start and end of the array, and then move them towards center until they meet each other. And along the way, we sum 3 values and push the triplet in the result if the sum is 0. And finally, we need to skip the duplicate value in the loop. If I did not make this clear, I confirm it will be really clear in our code logic. Let's look at our implementation. First, let us have this empty array, and then let's handle the first case. So if the length is less than 3, then we return an empty array. And let's sort the input array ascendingly. By doing this, we have sorted the input array. Now, let's loop through the array. Let's first consider a case here. If the current number is greater than 0, then we cannot find any 2 numbers on its right. Adding them together equals 0. Because the array is sorted, so any number on its right will be larger than this number. So if this is the case, we can simply break and return the result. Then we can claim our 2 pointers, start and end. And then we can have a while loop, and we move these 2 indexes in the center until they meet each other. Inside, let's first check the sum. If the sum is 0, we can push the triplet in the result. And then let's move the start and end. However, if the sum is less than 0 or greater than 0, we only move either start or end. If it's less than 0, we move start to make it bigger. If it's greater than 0, we move end to make it smaller. And finally, we want to return our result. How about the duplicate values? We can't return duplicate triplets. So in our case, we need to skip the duplicate value in the loop for both I, start, and end. Let's first look at our I. If the current value equals previous value, we can skip this iteration and move on. And also, because it's I minus 1, we need to have a condition check for I. I should greater than 0. And then, we can continue. Let's look at our start and end. So when we move start and end, let's check if the value equals. So if the start value equals previous start value, then we need to keep moving the start. And for the end, we do the same thing. At the same time, we also need to add this termination condition in this loop. So now we have skipped the duplicate. Then we can return. Let's submit. It passed. Let's look at the complexity here. For space, it's very obvious that's constant. For time, I think it's O of n squared. This is because we have two loops. So we have this outer loop from beginning to the end, and we have this inner loop. We have two indexes moving towards center. As a result, the time complexity is n of squared. Thank you for watching.